Boom. All right, Julie, welcome to Maths 125. And in this clip, we're going to be discussing the nitty-gritties of Maths 125. And of course, you know the title of Maths 125, right? Maths 125 is Differential Equations and Dynamics. Yeah, written by 4 authors. One of them is a professor. In fact, 2 of them are professors. One is a doctor. In fact, currently, 2 of them are doctors, 2 of them are professors, okay? The last person there happens to be Stella. All right, that is by the way. So let's quickly look at chapter 1. Chapter 1 is ordinary differential equation. Now, this textbook happens to be one of the most confusing textbooks you will have in this level. But the gospel truth about it is that it's pretty simple. And we're just going to touch the areas that we need, the areas of interest. And in this chapter 1, we are looking at ordinary differential equations, okay? So we're going to talk about ordinary differential equations, partial derivative, linear derivatives, order, degree, and that is that for the chapter. Nothing much. So the first part of it is ordinary differential equation, aka ODE. Now, an ordinary differential equation is actually made up of 3 basic parameters. Number 1, the dependent variable. 2, the independent variable. 3, a derivative, right? So once those 3 parameters are present, it's an ordinary derivative. You can give example, dy dx plus 3y equals to 3x, stuffs like that. Just write as many examples as you can. Make sure it has dy dx, it has the dependent variable, it has the independent variable. The dependent variable is always dy, while the independent is dx. So the one at the top is always dependent on the one below, right? So good. Having done that, we go straight to terminologies that we are going to see in ODE. What are the terminologies in ordinary differential equation? There are basically 1, 2, 3, or 4 terminologies. You hear things like partial derivative, partial DE, partial differential equation, linear differential equation, order, and degree. So we start with the very first one there, which is the partial DE. A partial derivative is an expression presented with respect to a dependent variable being arranged in the presence or midst of 2 or more other dependent variable. I know it's confusing. Let me take it again. This is an equation expressed with respect to an independent variable. An independent variable may be partial derivative of x expressed in the presence of 2 or more other dependent variables. Partial derivative of x all over the partial derivative of y and the partial derivative of theta, stuffs like that. Those are practical examples of a partial DE. And you can also see partial DE written as the partial derivative squared as a partial square derivative of u with respect to t squared being equals to c squared, the partial square derivative of u with respect to the partial derivative of s squared. So if you look at it very well, you have a total of about 3 variables there. You have u, you have t, and you have c. And x, I mean. Partial square derivative of u with respect to t squared is equal to c squared, partial derivative square of u with respect to x squared. So you can see you have 3 variables arranged in that manner. And then you can have multiple of them like that. You see them in your textbook. You can also see the partial square derivative of u divided by the partial derivative of x and the partial derivative of y minus the partial square derivative of u all over the partial square derivative of s squared. So if you are looking for the independent variable now, the one at the top is u, which is the independent variable. Now, if you're looking at the dependent variables, they are x and y, which are the bottom, okay? So that is what we call a partial derivative. A partial derivative is expressed with respect to an independent variable in the presence of 2 or more other dependent variables. Now we go to linear DE. A linear DE has 3 basic conditions to be fulfilled for a particular derivative to be linear. If you want to declare a derivative linear, if these 4 conditions, not 3. If these 4 conditions are not fulfilled, then obviously it is not a linear DE. Or if one of them is disobeyed, it's not a linear DE. Number 1, we focus on the derivative first. In fact, it's based on 2 things. Number 1, the derivative. The other part of it is simply the independent variables, okay? So the derivative law or condition says that the degree of the derivative must be equal to 1. The degree of the derivative must be equal to 1. That is the only condition attached to the derivative. Now, the second one is attached on the independent variable. Sorry, the dependent variable, which is y, not independent. Y, the dependent variable. So, and the law says that the degree of the dependent variable must be equal to 1. That's 2. Then number 3, the derivative should not be a product of the dependent variable. That means the dependent variable should not be a product of the derivative. Then number 3, the dependent variable should not be a transcendental function. So when we talk about transcendental function, we talk about functions that are expressed in terms of trigonometric, in terms of exponential, in terms of ln. You understand? So those are transcendental functions. For example, sine y, e raised to power y, ln y, stuff like that. They are transcendental. And once the value of the dependent variable assumes transcendental, then assume it not to be a linear DE. So just to quickly recap that, there are 4 conditions that makes a DE linear. Number 1, the derivative must have a power of 1. That's a degree of 1. Then number 2 and 3 and 4 are focused on the dependent variable. The dependent variable should not be a product of the derivative. The dependent variable should not have a power greater than 1. That means the degree should not be greater than 1. And then lastly, the dependent variable should not be a transcendental function. Good. So that takes us to the last part of this chapter, which is purely order and degree. Now, what is an order? Order is simply the highest derivative of a DE. That's the order. Highest derivative of a DE. Highest derivative in the sense that you look at the third order, the fourth order, the fifth order, the sixth order. If it's first order, the highest derivative there is 1. If it is second order, d square y dx square, the highest derivative is 2. So that is the meaning of the word order, the highest derivative of the DE. Now, when you talk about the degree of a DE, you're talking about the power of the highest order, or the power of the highest derivative. So if the derivative, which is the highest DE, is d4 y all over dx4, look for its power. Then you will know the order, so the degree of that particular DE. And take note, once a fraction covers a DE, in other words, once a fraction or once a derivative in a DE is raised to the power of a fraction, be rest assured that you have to get rid of that fraction so as to determine the real degree of the DE. By squaring both sides if it is half, by cubing both sides if it is cube, by fourthing both sides if it is 4. But if a fraction is on the dependent variable, for example, that does not affect the derivative, then be rest assured that it has no business with squaring. Once it affects the derivative, you must get rid of that fraction before you pick your DE. That is, before you pick the degree of your DE. That is exactly what we're trying to say. So basically, that is the end of this chapter. Nothing much. That is exactly what I've told you. So if you look at your textbook, although this textbook is one of the most confusing textbook one can ever see, but however, if you look at it, the very first page there is differential equations in mathematics models. And then the first part is identification of the dependent and the independent variables. So they have about 9 questions there. You should be able to identify all of them. And then the exercise 1.2, which is based on linear. You should be able to look at exercise example 1.1. I think they're about 1 to 5. And then you also have them 1 to 4. You should be able to pick up the linear DE from the non-linear DE there, as the case may be. And then also, if you move further, forget about the part of the question that says state the function attached to each of the equations as a solution or not. Ignore it. Those ones are just further chapters, okay? So the next thing you go, continue going further until you see example 1.3, which is focused on degree and order. They will ask you to determine the degree and order of the following DEs. So from there, you can give it as an assignment or solve it in class. And then also, if I finish that from question 1 to 10, linear and non-linear, you should also be able to answer that. Then from question 11 to 14 at the back, ignore. You see them in further chapters, okay? Because those ones are just there to bring confusion. Thank you for listening. This is the end of chapter 1. Boom. Let's enter chapter 2. Maths 1 to 5.